Dear students, today's topic is minimum deviation through a glass prism. To begin with, we have considered the prism A, B, C in which the incident ray is incident on side AB at point P. You can write the name of this incident ray as incident ray, and sorry for this noise, right? So many games are going outside. So it is incident at P. Now it is going from the outside air to the glass prism, from air to the denser medium. Now what happens is that there will be refraction of light and it is bending towards the normal. So if there was no prism, then it would have gone like this, but it deviated towards the normal because this is the normal going from rare to denser, and it meet another surface A, C here. Now what happens is that if there were no glass, if there were no air, this was extended. If this glass prism was up to here, then this light would have gone like this. Okay, but this is air and this is prism. It is going from denser to rare. Now it has to move away from the normal. So this is the normal and it moved away from the normal, and this is the emergent ray. So angle between this normal and this incident is angle of incidence, and angle between this normal and this emergent ray is emergent angle. So what are R1 and R2? R1 is the angle of refraction at A, B, and R2 is again the angle of refraction, or say the angle on A, C. Having said that, it is also clear that angle I, this angle, this and this angle should be equal to this and this angle, which is angle I. Okay, and this angle is angle emergent. Now what I do is I will take this backward, tracing the backward, and I get this much, and this angle is my angle of deviation delta, because it was going like this and finally it went out like this, emerged like this, and this is the angle made. So this is my angle of deviation. So let us begin the theory and the derivation part. So there is one quadrilateral. Okay, so quadrilateral A, P, Q, R. Please figure out A, P, Q, R is the quadrilateral, and all the angles, if I add all the angles, say angle A, so this is angle A, so I will write angle A plus angle, say A, P, Q, angle A, P, Q plus angle P, Q, R plus angle Q, R, A is equal to 360 degree. That is the angle sum property of quadrilateral. This angle, this angle, this angle, and this angle. Okay, please see it very carefully. This angle, this angle, this angle, and this angle is 360 degree. But what is this angle? How much is this angle? This and this. How much is this angle? Can you see? This is normal and this has to be 90 degree. Means A, P, Q is 90 degree. Okay, and this angle is again 90 degree. Q, R, A is again 90 degree. So this is the case. So this is also Q, R, A is also 90 degree. So 90 degree and 90 degree is giving me 180 degree, and I take this side. So 360 minus 180 degree is 180 degree. Then angle A plus angle PQR is equal to 180 degrees. Say equation number 1. Is that clear? You have to be. Now I will take another triangle. Okay, another triangle which is PQR. So triangle PQR. So angle sum property is, if I add all the triangles, all the angles, then I should get 180 degree. So the angles are R1 plus, this is R2 plus angle PQR is equal to 180 degree. So equation 2. Are you getting this or not? This angle plus this angle PQR. So it give me 180 degree. Now see equation 1 and 2. This is also 180, this is also 180, then this has to be equal. So therefore what I write, comparing equation 1 and 2, this is angle A plus angle PQR is equals to R1 plus, this is R2, sorry, R2 plus angle PQR. So both side plus PQR cancels and get angle A is equals to R1 plus R2. So this is equation number 3. It is as simple as this. Okay. So what is A then? Angle A is equal to R1 plus R2, equation 3. We are done now. We are almost done. Now say what next? What to do in the next case? Okay. So in the next case, we will find how much is the deviation, by how much angle the incident ray is deviated. So there is two deviations. First, it was going like this. It was going like this, and because of this prism, it deviated like this. So I am writing here small angle. This is delta 1. Why I am writing delta 1? Because this was going in this fashion. Because of the glass prism, it deviated. So this is the deviation delta 1. But not only one time. Deviation takes place 2 times. Here, it was going like this. Can you see it? But it is going from denser to the rare medium. Instead of going in this dotted line, it deviated downward. So I will write this as delta 2. Understood? So this is delta 2 and delta 1. Now how much will be the deviation delta? This should be equal to delta 1 plus delta 2, because there is deviations of 2 times, right? So the deviation is equal to deviation delta is equal to delta 1 plus delta 2. So this is very sure. Now how much is the delta 1 and how much is the delta 2? So if you see here, delta 1 plus delta 1 plus R1 should give me I, because delta 1 and R1 is I. I have already told you this whole angle, it is like this, isn't it? If this is 30 degree and this has to be 30 degree, vertically opposite angle, and here is my delta 1, this is R1. So R1 plus delta 1 should be equal to 30 degree, which is my I. Is that clear? Good. So now delta 1 is equal to not delta 1, let me write I is equal to delta 1 plus R1, implies this. If I take this delta 1, then there is I will take this here minus of R1 is equal to delta 1. I got the value of delta 1. Similarly, I will get the delta value of delta 2. How do I get the value of delta 2? Now please think of the situation. This is going to give me R2. Why this is R2? Because I have this angle, okay? This and this. Can you just check it here? I guess you can. This is R2. Then this has to be R2. And I have one thing here, which is delta 2, and this is E, isn't it? So this R2 should be equal to R2 because vertically opposite angle. Then how much will be E? So E is equal to R2 plus delta 2, isn't it? R2 plus delta 2 is E. Then I am interested on delta 2. So there is E. I will take this R2 here. So minus R2 is equal to delta 2. So I got delta 2 as well as delta 1. Then how much will be the delta again? Tell me. So therefore, in the last step, so delta is equal to I minus of R1, then plus is plus E plus minus minus of R2. So this could be the most easiest derivation that we can have, right? So then what I do is, then implies this delta is equal to, this has to be plus. Okay, not plus, it has to be minus. Oh my god, this is I and plus of E, then minus R1 minus R2, then implies this delta is equal to I plus of E minus कॉमन लेंगे तो क्या होगा R1 plus R2. सही बात, क्योंकि हमारा वैल्यू R1 plus R2 we have already got it as angle A. So then delta is equals to I plus E minus angle A. This is equation 4. So the delta is equal to how much? Tell me. The delta angle of deviation is I plus E minus angle A, equation number 4. Having said this, we have got the minimum angle, not the minimum but the delta. Now we are interested in finding the minimum angle. So now we'll consider a particular angle. Let us consider a particular angle in which the deviation is minimum deviation, right? Now when there is minimum deviation, this refracted light PR travel parallel to the base BC of this prism. It is very important point. Okay, now at this situation the angle of deviation will be minimum. Okay, that is called the minimum deviation. Now when it will happen? When it will happen, let us consider at any particular angle of incidence, the angle of deviation is minimum. That time this PR ray travel parallel to BC. Now so is the case for delta M is for minimum deviation. This will become R1 will become R2 and I will become E, right? This is for minimum deviation. Then the angle A will got changed. So therefore angle A, that is for the minimum deviation, will become, say R1 is equal to R2. I will write just R plus of R. Say R1 is equal to R2 is equal to R. Say, okay. So then angle A is equals to 2R implies this angle A by 2 is equal to R. So we got angle A is equals to A by 2 is equal to R. So this is equation number 5. We got this from this. It is now very simple. Now what next is here. Now what I do, therefore delta is equals to, I will write I plus of I minus of angle A. Why? Because I is equal to E. Instead of E, we can write I. Okay. Now this delta, I will take this angle here, it will become plus angle A equal to 2I. Now this is going to give me delta plus angle A whole divided by 2 is equal to I. So we got the angle of incidence I also. So what is I? Sorry. Here I have to write delta M. Please write here delta M. Why delta M? Because we are considering the minimum deviation. So I have to write delta M. Okay. So everywhere delta M. Then this I is equal to delta M plus angle A by 2 equation 6. You can have this equation as many as possible. Now what we are going to do in the next topic, let us find the refractive index. Okay, our main aim is to find the delta M is how much. Okay, from the beginning we did so many things to find delta M. Now lastly there is refractive index. What we know is refractive index of 2 due to 1 is equals to N2 by N1, which is equal to sine of angle of incidence I divided by sine of angle R. That is the reason why we find R and why we find I, because from the definition of refractive index I need to have I and R. If I substitute the values of I and R, then I should get what I should get. Say N, I will just write N. Okay, N to 1 everyone knows. Let me write just N is equal to sine whole divided is there. What is I? I is delta M plus A by 2. Here this angle A is as same as A, which is called the angle of prism. Okay, so this is the angle of prism. So this is A. Okay, now there in the downward, that is in the denominator, this will be A by R. But still we are not getting the delta M. So how to find the delta m, minimum deviation? Now what we do is, we'll assume, okay, what we do is, for the minimum deviation, the angles are very small. For minimum deviation, the angles are every angles. This angle, this angle, this angle are very small angle. Now for a small angle, what we can write? For a small angle, you have to write for a small angle at minimum deviation, and is going to give me almost equal to delta m plus a whole divided by 2 whole divided by again, so, okay, not sine will be remained out, a by 2. So this is 2, not r, this is 2. Okay, then this denominator 2 and this denominator 2 will be cancelled. Now if this get cancelled, then n is equals to delta m plus a divided by a. Now we are done. Okay, so then this will become n a equal to delta m plus of a. Now we are interested on delta m, then this will be n a minus of a equal to delta m, then implies this a and a is common, then n minus of 1 is equal to delta m. So eventually we get delta m, which is minimum deviation, a n minus of 1. This is the situation. Okay, so this is all about the theory of the minimum deviation. Now say there is another way to find the minimum deviation using the prism with the help of a practical. So for that practical, in one of the side, what we do is, we'll take this angles, okay, and we plot the angle of this angle incident versus angle of emergence. So for that I will get this kind of graph. Okay, now whatever is this point is the minimum point of this graph, and if I extend this here then this will be minimum deviation. So for the different points will be here for different angle of incidence and angle of emergence. So we are going to get this kind of graph in the experimental part. For today's lesson, this much. Thank you.